you should be talking more, but that's okay, and you're still eating. So yeah, so welcome everyone to CJUG. And for this particular meetup, we're very happy to have Marcus Hellberg from Vaadin here. And we're going to be talking about really like generative AI and for Java. So this is very exciting. So thank you. And let me move forward with this. First of all, let me mention too, we're going to do 2 raffles, like of the JetBrains licenses. So if you're interested in it, you can fill out this form. And this is bit.ly link and also the QR code. If you miss it, actually, I can also share with you the link to this slide deck too, in case you miss it too. So, and I can show this to you again if you need it. So, yeah, good. So the only rule to this is that you are not eligible to participate in it if you have won a license within the past 9 months. So then you would give more chances for others who haven't won yet. So, oh, sorry. Is it good? Did you all take it? Yeah, good. Okay. No, somebody said, oh, okay. Good. Okay, cool. Okay, so just some housekeeping. And remember, we have our Chicago Tech Slack. If you haven't already joined it, there are, I think, over like 12,000 people now from not just Chicago. Some people are outside of the area too. So it's just kind of a nonprofit Slack channel for folks to be exchanging messages. And there's also a job posting room too in there as well. And then there's also Java Off Heap from our previous CJUG kind of group of folks, including Freddie Gemay and Bob Paulin. They're still doing the Java Off Heap podcast. And also we are on meetup.com. So if you haven't already joined us there, please sign up with us so then you can receive our announcements of all of the events, upcoming events, and communicate with us there too. And if you haven't already followed us on X or the former Twitter, this is our handle at CJUG. And we also have our Discord channel too. And we are encouraging you to engage with one another and also with sometimes with speakers who have signed up to on our Discord server. And I've also always we always create a special room for the particular meetup too, in case, folks wants to have more conversation around the topic of presentation too. So that's the particular room, but otherwise you can join our Discord server there. So this is the link. And some community info. So we are a community partner of the following groups and conference organizations, including JetBrains, who have been very generously donating like 2 raffles every month to us. And then there's also a devitjobs.us. They are job what you call a job search site. So you're welcome to join that. And then there's also a conference called We Are Developers. They are international too, but they are based in Berlin. So we're also partner with them. And also JCon in Europe too. And there will be one JCon coming up in May 13th to 16th in the next slide, that are giving out free JUG members pass too. So, and there's also one more conference called CodeMotion that's also based in Europe. They're also having like free code, or not free code, I should say discount code too. So if you happen to be in Madrid, you're welcome to join them too. Okay, so this one is JCon Europe. That's the link. And then also free admissions for JUG members. It's this bit.ly link here. But then if you go to the main site, you can also get to that tickets kind of tab to find how you can sign up for free admissions to that conference. And then this one is CodeMotion. There's also a special code for CJUG members, which is here, partner_CHI, if you decide to go to Madrid in May. So, and some upcoming events, we will definitely now actually have an event in April. Most likely it's April 17th. Right now, just deciding on the speaker, and also in May, like the 3rd or the 4th week too. So yeah, stay tuned for that. And then other confirmed speakers will include Venkat and Alina Urenko from Oracle, and also from Oracle, Josie Pomal too. They're Oracle developer advocates too. But it's just, we haven't been able to find time to kind of confirm with them, but they are interested in speaking for CJUG. And then we're still trying to ask if anybody is interested in doing unconference style meetup too. So if you're interested, please feel free to reach out to myself or Jay or Josh Austin, who's there, and also Nick, and yeah. So if you're interested in giving us ideas about doing an meetup. And if you're interested in speaking at CJUG, you can always send your proposals to present@cjug.org. And now, I'll give just a few minutes to all of you if you're interested to share your story with the community. If you feel comfortable sharing your story, if you're looking for jobs or looking for project collaborators, or if you're recruiters looking for candidates, you're welcome to share your story now. Does anybody want to introduce yourself, or yeah, no? I think we're quiet today. I think last time we had somebody who actually was sharing his story. That was real nice. So no, yeah. So I'm not going to force you, but if you're interested, you can also stay behind, and we're going to have more social networking afterwards too. And if you feel more comfortable talking one-on-one too. So, all right. So, okay. So just a few words about our sponsor, but this year, unfortunately, all of our sponsors are not able to continue sponsoring us, but we do want to recognize JFrog, who actually were sponsoring us in the past 3 years or so. So I want to say thank you to JFrog again. And then also Fusion Auth was our sponsor, silver sponsor last year too. So they help us a lot too. And these are friends of CJUG. We have the worldwide Java community behind us, and in particular, the Atlanta JUG, the Boston Java user ACM chapter of New England, Garden State JUG of New Jersey, Kansas City JUG, Missouri, the New York Java SIG in New York City, and also Pittsburgh JUG in Pennsylvania too. So these are our special friends of CJUG. So, and they sometimes are still doing live stream too, so you can go and visit them, see what they have too. And now I'll introduce to you our speaker for today, Marcus Hellberg, and he's the VP of Developer Relations at Vaadin. And this is his personal website over here. And he specializes in modern web technologies, Java, and developer relations. And he's originally from Finland. And now he lives in San Francisco Bay Area. So the stage is yours now. Thank you, Marcus.
Thank you, Mary.
Thank you. Oh, yeah.
All right, give us just a moment here. I'm gonna do the 2 microphone thing now, so we get everyone on the stream and everyone in the room. Perfect. All right, so hello. Yes, my name is Marcus. Let me switch over to my slides, if I can figure out how to do that. There we go. Slideshow. It's working. Good. We had a lot of trouble getting this working earlier today. I feel like the volume's a little high on this. It's like if I talk even a little bit too loud, it starts to give me a feedback.
It's too bright here, maybe we can dim the light.
Okay. Sorry about that. See if I point it away from my mouth, maybe that's like enough of a volume lowering. Good. All right. Well, thank you all for coming here. It is awesome to see so many of you here in person. I'm going to start with the mandatory room selfie, just so I can show everyone at work that I actually did speak to people. I didn't just come to Chicago to have awesome Domino's pizza, which I think you're famous for. No? All right. So if you don't want to be on the picture, go hide. Perfect. All right. So today we are going to have a fun live coding adventure. We are going to learn about building AI-powered applications, specifically in Java. We're going to have a React front end for them, and we're going to do all kinds of cool stuff. So if you came here to Slack, this is unfortunately not the place. So I will need you to pay attention and help me figure out all the things I do wrong in my live coding. But otherwise, we are ready to get going. So as a person, I am a very curious human being. I like to like tinker with things and understand how they work. And when AI started to become more of a thing, ChatGPT came out, and started playing around just to kind of see what it does, and it was really interesting to me. So that kind of sent me out on this journey of trying to kind of see how I could use it for more useful things than just kind of having it write tweets for me. So this here is my dog, Nova. Nova is 11 years old. She's an old lady. And as an old lady, she has some aches and pains every once in a while. Last fall, she needed to go and get a CT scan, and the radiologist, in his infinite wisdom, decided to send us the report for the scan by printing it out, putting it on a table, taking a picture with his cell phone, and sending it to us in a text with no context. So we're like, huh? Like, it was densely packed medical jargon. I did not understand if it was good or bad, or like, is she dying? Is she okay? Anything in between. So I, as a nerd, turned to ChatGPT. I uploaded the picture and I instructed ChatGPT, you are a radiologist who happens to be good at communicating with human beings. Can you please read the report here and summarize the key findings to me in an easy to understand way? Sure enough, I get a couple of bullet points saying like, this is going on. And I could figure out like, yes, there's nothing terribly wrong. She's an old dog. She has some aches and pains, but she's going to be fine. So that was like immediate release for me. And sure enough, the doctor did call us like 4 hours later and explain the same thing. But that was like 4 hours of worrying I didn't have to do. So I think there's tremendous amount of good stuff that we can do with AI if we're applying it to proper things. But also, if you've ever used ChatGPT for stuff, sometimes it's just like really dumb. It's just like, how do you not understand this very simple thing? Like on a kind of high level, if we look at what a large language model, an LLM is, it's pretty simple. You give it a prompt or a question, magic and unicorns happen in between, and then you get an answer. The problem really comes in when you're trying to do something that's more specific, because LLMs in their nature are very generic. They're good at answering general questions, general knowledge questions. But what we're trying to accomplish in our day-to-day work is very specific to what our business happens to do or what we're interested in doing. And there's kind of a disconnect there. Vaadin, as a company where I work, we have open source frameworks for building web apps for folks on Java backends. And specifically, we're helping people build these business apps, which are kind of the, if you will, the boring apps that run the back of the house, the kind of apps that run the entire world behind the scenes. And for me, looking at AI, I started thinking about all those really kind of boring, tedious, time-consuming workflows that all these people at offices are spending 8 hours a day doing. And I'm like, well, surely we can use this to kind of automate some of that so they can like just check the work of the AI instead of like moving one piece of text from one field to another and just like slowly die internally 8 hours a day. So that set me on a mission to try to kind of see what can we use as Java developers specifically, because I'm a Java developer. I didn't want to do this in Python or JavaScript. I wanted to do it in Java. So how can we do that? So one way of looking at this whole thing that I think is helpful if you're coming from a kind of computer science background is thinking of the LLM as kind of the CPU in a computer architecture. In and of itself, it's just a general purpose piece of hardware that's able to do some work. But in order for it to be truly useful, we need to hook some peripherals to it. At a very minimum, we need to add some sort of working memory so it remembers what it's doing, so it can perform things, remember the previous thing it did, and then kind of build on top of that. More likely, we are going to need something like a vector store, kind of permanent storage for stuff so that we can store more than we can just put in our working memory at any given moment. Very likely, at some point, we want to give it some tools so it can perform some tasks for us so we don't have to do everything ourselves. And we might even want to delegate some tasks to other LLMs. So maybe we want to have a image generation performed by like a diffusion AI instead of our large language model. So if we start looking at the LLM as more of a CPU in this architecture, it kind of helps us understand what's happening. This is going to be a very kind of AI for engineers talk. I'm not a data scientist, or my understanding of the math going happening underneath the APIs is kind of limited at best. I can probably understand the basics of how a neural network works, but we're not going to do any math today. We're just going to look at an API that we can call, and we're going to get an answer back from there. And we don't really care how the sausage is made as long as it tastes good. We're all happy engineers. Today, we're going to work with two libraries, LangChain4j. That's an AI library for Java that kind of got its start as a Java port of the Python LangChain library. Today, it's taken influences from a lot of other Java AI or other AI libraries, so it's not like a straight up port anymore, but it's a very helpful tool for us to kind of work with AIs without having to be on a very kind of low level of API. The other tool we're going to use today is called Hilla. It's a framework, one of our open source frameworks, which kind of hooks a React front end type safely to a Spring Boot backend. So that's going to allow us to build a UI for our app very easily. I'm going to kind of structure the talk along this axis of agent autonomy. I initially started when I built this first version of this talk, I had a whole cool fun meme thing that tried to explain the same thing, but then I found on Microsoft's semantic kernel page an actual like serious diagram that explains this. So we're going to go with that. So if we think about how AI can help us in an application, there's kind of a line of giving more and more autonomy to the AI. So at the kind of least autonomy end of the spectrum, we have something that's like a chatbot. It can answer questions. This is like the early versions of ChatGPT. You could have kind of dialogues with it, but it's limited to very basic understanding. It can't go to the internet to fetch things if it doesn't know. It can't access tools. It can't do this. It can't do that. If we want to do something that's more kind of meaningful in our business setting, we likely need to go at least to this retrieval-augmented generation, or RAG, where we teach the LLM some specific things about our context, or we give access to it to retrieve this information as it's working. We could take things one step further and give the AI a limited set of tools and say like, hey, like if you know how to use these tools to perform tasks for me, go ahead and do that. That can be really helpful. Then we're kind of in a co-pilot situation where the AI is able to do some things that we allow it to do, whereas we're still in the kind of driver's seat and we are the ones deciding what should be done and shouldn't be done. And then all the way at the other end of the spectrum here is a fully autonomous AI where we just say like, hey, book me a restaurant for tonight, and it will figure out what kind of food I like, which restaurants have openings today, when my calendar has time, like how long it's going to be to drive to that restaurant at that time of day, and all of that. It would just figure that out and do it for me. We're not going to go all the way there today. We're going to stick to the kind of co-pilot and retrieval augmented generation, which is where I think most AI systems sweet spot is when we're dealing with business apps, where it's not like, well, just figure out my taxes and hopefully it goes well. We're not there yet. We might be there in a few years, but not today. So if we start looking at a chatbot, so we're kind of at that lowest level of autonomy. Essentially, when we're looking at our diagram, we're simply using the LLM and its context window, which is kind of the working memory of the LLM. Some stuff that we want to do at this level is being able to kind of interact with an LLM. And for it to be kind of pleasurable to do this, we want to have a nice abstraction over the underlying LLM, because there are a lot of different language models out there. There are new ones coming out all the time, and we don't want to keep rewriting our app every time a new one comes out. And like we were looking earlier in the diagram, there are different AIs that are specific to different tasks. So we might want to use one for one thing and one for another, but we don't want to kind of keep rewriting our application. Another thing that's really something that we want to have a tool like LangChain do for us is managing this working memory for us. So the context window is essentially where we need to fit everything that we want to talk with the LLM about. So it's typically anywhere between 4,000 and these days up to like 250,000 tokens worth. A token is like a subword that the LLM uses when it splits up text into mathematical representation. So if you have like a 4,000 token window, that's roughly 3,000 words of English language, give or take. But we need to fit a whole bunch of things in there. So we need to fit the system prompt. In my example with my dog, that was me telling the AI that it should behave as a radiologist that's capable of communication with humans. So that's a system prompt. How should it behave? We need to always send the entire history of our conversation to it on every single interaction, because it, again, like the CPU, it doesn't have any memory in and of itself. So if we want to ask it something that was in relation to what we talked about earlier, we need to actually provide that to the LLM. Of course, we need to have our question that we're asking. Most likely, we want to also include some information that's relevant for answering that question. That's where the retrieval-augmented generation comes in. And we need to make sure that there's enough space in that memory for the actual answer to be generated. So if you have a 4,000 token window, we can't put 4,000 tokens of input there, because then it doesn't have any place to put the output. So when I did my first retrieval-augmented generation app like a year ago, which is in AI years, maybe like 2 decades, I had to do all of this math by hand, count how many tokens I'm using for this message, and how should I pop up this one message when the history becomes too long and stuff. These days, we can use libraries like LangChain to say like, hey, when the history gets longer than this, like start leaving out older messages or summarize the discussion up until that point. So keep on the computer memory the whole discussion, but then summarize it for the LLM. With these kind of longer 200,000 token windows, it's very tempting to just like, well, I'm just going to send my entire library documentation over to the LLM and let it figure out on its own. The problem with that is that we're getting billed by the number of tokens we're sending. So if we want to be kind of budget conscious and not like rack up a huge AI API bill, we want to be pretty conscious about what we are sending over. And again, this is something where retrieval-augmented generation is going to help us out a lot. We're also going to need some sort of templating language, similar to how we have templating language for producing HTML. It's very handy for us to be able to produce these prompts based on templates, especially when we start tying together multiple operations where one AI call leads into the other, leads into another. So being able to pipe the output from one into a certain template on the next one is going to help us out a lot. And finally, we want to have a library like LangChain help us get the output in a format that's actually helpful for us. So by default, all the APIs are just JSON APIs. We get some JSON. But if we're using a library like LangChain, it can give us that result back as a Java object of a certain type. So that's, again, right away, that's going to be a whole lot easier for us to work with as Java developers than getting a JSON string back. Good. All right, so that's the very basics of just us talking to the LLM. When we start looking at retrieval-augmented generation, this is where the business specificity comes in. So this is us adding some sort of long-term storage for the LLM, where it can go and fetch data essentially that's relevant for that particular operation. And for us to kind of understand how this works, it's good to know what an LLM knows and what it doesn't know. So essentially, they know everything that they've been trained on. For big models like OpenAI and Gemini and stuff, that's essentially the entire internet up until some point in time. The other thing that they know is whatever you give them as a part of that context window in that working memory. So the way we could go about teaching that AI or large language model something specific about our business is, one, train our own model. If we're billionaires, this is a really good way of going about it. Another much cheaper and easier option is fine-tuning existing models. So you take a model like GPT-4 and you teach it some additional things by providing it some examples of, like, if you get this type of answer input to answer this. And that's fairly cheap and doesn't take a whole lot of time. But there's an even easier way, and that's just putting the relevant things into the context. So this is essentially like an open textbook test. You just tell the LLM, like, here's the book, it's open on the right page, go and answer this question with the information provided. And usually it does a really good job at that. For it to do that, though, we need to figure out what is the relevant context to send open, like what page should we open up in that book? And again, we're getting billed by the amount of tokens we're sending over to the API. So we don't want to send the entire book. We just want to send the exact page that's relevant. So today we're going to work with an example of a kind of a travel booking site, and we have a terms of service document. Now, this is a very simplified thing where obviously we could send these 3 paragraphs to the LLM and that would not be a problem. But for the sake of argument, here's what we want to do when we're doing retrieval augmented generation. We want to take our documents and we want to split them up into meaningful segments. We're then going to take each segment and turn that into a vector embedding. So a vector embedding is a mathematical representation of the meaning of a text. And that's kind of weird, sort of to understand, maybe if you haven't worked with it before. But I like to use an example of a color picker to really explain how this works. So if you've ever used a color picker, you know that you can select essentially any color in the spectrum and you get a RGB value, a three-value vector representation of that color. So intuitively, you know that similar colors have very similar vector values and very different colors have very different vector values. So essentially, we're just doing the exact same thing with text here. Obviously, there's a lot more math happening, and the vectors are not 3 dimensions. They're typically 1,500 to 3,000, 4,000 dimensions, where each dimension is like how similar is it in one particular regard. We don't know exactly what those regards are, but they do a very good job of kind of encoding the meaning of that text. So it wouldn't actually matter what language those texts are in. The vector embeddings would be the same. So it's not encoding the semantic like text or the actual text there. It's encoding the meaning behind the text. And the reason why we want to split this into sections is the same as why we can't ask a color picker, what's the color of this entire image? It doesn't make a whole lot of sense. Or you could probably calculate some sort of mean value of the entire image, but it wouldn't be super helpful. It would be much more helpful to be able to say, like, what's the color of the cap of my water bottle? So similar here, if we have kind of split the text into meaningful sections, so say if you have markdown, if you split it by your headings into sections that have to do with one thing, then it's much easier for us to ask, like, what's the meaning of this paragraph versus what's the meaning of this entire book? All right, so we've done this. We've called an API. We've gotten this vector representation. We're not doing the math ourselves. We put it into a vector store, which is a database that deals with vectors. We store both the text and the vector representation of it so that when we ask a question, like what's the cancellation policy, we can run the same API call to get a vector representation of that question, and then ask the database for the most similar documents to that. Because our question has something to do with cancellations, the most similar document in our vector database will be the cancellation policy, because that also has to do with cancellations. So that way we can find just the kind of most relevant piece of information to include in our call to the AI. Good. So already at that point, we're going to be able to do a lot. But where things get even cooler is if we add some tools for the CPU, some programs for it to call. So this is essentially telling the AI, like, hey, you can use these handful of tools as you're answering. And that way we can kind of offload some manual labor to the AI, which is, again, sort of the point of an AI. It can do things for us. Good. All right. So that was, I wanted to just start with a little bit of theory, just so you understand what's happening as we're doing the coding. But obviously we're here, we're Java developers, most of us at least, but you're very welcome to stay even if you're not. We're going to build a little application that looks like this, where we have kind of simulated airline bookings, and then we have a customer support agent that we can ask things about our booking, we can ask about our cancellation policy, we can ask it to change our booking, we can ask it to cancel our booking, and it'll check our terms of service document to see whether or not we're allowed to cancel or not. And it's going to do a lot of things for us. So I think it's pretty fun little example and gives a good kind of view into all of these different parts of building a AI application. So let me go in here, and are we still good on the font size? Everyone in the back, thumbs up. Good. And you can see this. Let's make that a little bit bigger. So what I have here is a kind of a live view of the simulated database. I don't have an actual database. It's just a array list in memory, but it pretends to be a database. So this shows like what the database is at any given time. And here is where we can chat with our chatbot. So if we say hello right now, it's going to say, Oh, let me see. I need to build that. I was running through this, so it's already had the solution there. So let's see if this works. Hello. All right, so now it's saying like, hello, my brain is not hooked up yet, and we need to actually go ahead and do that. So before we start actually coding, I want to just show you real quick where we are and where we're starting from. We're starting from a Spring Boot application. So we have a Spring Boot 3.2 application. We have added some dependencies to it. So we have Hilla, which is the framework, open source framework that we have that combines a Spring Boot backend and a React front end. We have added LangChain4j here. We're specifically adding their new Spring Boot starter here. They're very kind enough to actually do a PR on my project yesterday to provide this. So with these AI tools, they're moving at breakneck pace. So what we're seeing here was released yesterday. So if something doesn't work, it's probably because it's very new, but it's also very exciting. I'm also bringing in dependencies for a in-memory embedding model. So something that takes a text and gives us that vector representation of it. And we're also going to use an in-memory database to store those. Everything here is behind an interface. So you could start out with this very simple in-memory one, and then you could swap it out for a more proper one as you're getting farther along. But this is great. And the reason I did this is because you can then check out this project and you can run it on your computer without having to set up a whole bunch of different external pieces. All right, so what I've done in my application properties is I've set up a couple of properties here for LangChain. So one is I'm providing my OpenAI key for the streaming chat model. We're going to use the streaming model where it's going to provide the result as it's getting generated, similar to how ChatGPT works, where it's kind of writing out one word at a time. And I'm providing the model name that I want to use. So I'm going to use ChatGPT's GPT-4 Turbo model for this. And you can change the models that you're using if you want to use a different one. Good. And I have a couple of things in my project from before. One is just a Spring Boot service that provides details for fetching and persisting flights. We're not going to look at that because it's not relevant. And then we have this service here, which is a Hilla specific thing. So I have a Spring Boot Spring class here that has a public method, and I've added this browser callable annotation on it. That means that in my React code, I can call a method with that same signature in TypeScript and subscribe to the flux from my React code with full type safety. So we're obviously at a Java meetup. I'm not going to show too much React code. I did see your React t-shirt, so you might not be scared, but I know there are people here. It's late, and I don't want to like give you nightmares or anything. But we have a grid here that displays the database, and then we're just mapping over each message that we have in the history and just displaying them there. And on the message input submit, we call this send message that then calls our service. So now we're all in our Java backend, and we want to start building this out. So I created this LangChain4j package here, and I'm going to use it to just contain all of our code here. The first thing I'm going to do is create an interface that describes how I want to interact with the LLM. So I'm going to call this my assistant, like this, and this should be an interface. So this is similar to like you defining, say, a JPA repository in Spring Data, and then Spring provides you with the implementation for that. We're now defining an interface for an AI thing, and we're letting LangChain4j provide the implementation of that for us. So we're going to say that this is an AI service, and we're going to have one method that returns a token stream. The method name should be chat. It's going to have two parameters. One is a string for the chat ID. So each chat will have a separate ID, so we can keep track of your message history versus your message history without them getting all jumbled up. And the other one will be a string for the user message, like this. I'm going to add some annotations here for LangChain. So this will be the memory ID. Now LangChain knows that this is the key it should use to manage the memory with. And then this will be the user message like that. Good. All right. So we have that here. We're going to go into our service that we're calling from the client, and we're going to auto wire in this. I'm going to do a private final assistant. We're going to call this our assistant, and then we're going to auto wire this in. This is a bug in IntelliJ that I just reported. They're looking into it, but it's saying it can't find it, but it's going to actually work for unknown reasons. So what I want to do then is I want to turn this token stream that I'm getting from the assistant, which is a LangChain4j specific data type, into the more kind of standard Flux data type, which is from the project reactor library that Spring uses for a bunch of reactive things. So Flux is essentially just a data type that we can subscribe to, and whenever a new value comes in, that will get passed to us. So for that, we're going to just manually map between these two. So I'm going to create a sync of type string. And this will be syncs.many. We do this. All right. So we're essentially saying that we have many values. They're all going to one person, the person who's chatting with us. And if for whatever reason the client isn't able to kind of consume these as fast as we're sending, don't drop words from the middle of a sentence. That would be super unhelpful for what we're trying to achieve here. And then we're going to return the sync as a flux. And in between here, we're now going to call the AI, and we're going to map these two things. So we're going to call the assistant chat. We're going to pass in the chat ID and user message that we're getting from the client. Then we're going to say that on the next value, we're going to do sync.tryEmit next. So essentially, we're just mapping between these. I've been talking with the LangChain4j folks. They might provide a way of just getting the flux directly, but this is what we're doing today. It's not a whole lot of extra work. So on complete, we're going to call sync.tryEmit complete, and then finally on error, we're going to do sync.tryEmit. Sorry. Sync.tryEmit error like that. And then finally, we're going to call start on it. All right. So a little bit of kind of plumbing code here, not too crazy. What I'm going to do then is I'm going to build a project. So I'm going to go build project. I'm just going to use the keyboard shortcut here. And I am missing something. Oh, yeah, I'm missing the return here. All right. So if you see me doing stupid stuff like that, just point it out. Okay, so you can see our page get reloaded here. That's a feature built into Hilla. So whenever you change your code, whether it's front-end code or back-end code, it's just going to live reload that in the browser. And I'm going to use the dictation here to say, hello, my name is Marcus. I'm going to hit OK here. It's going to respond with something. I can, hey, I forgot my name. What is it? Okay, so now, since we haven't hooked up a memory to our AI yet, we're literally using just the CPU. It's not super helpful. It doesn't even know who it's talking to. So obviously, for us to make this a little bit more useful, we need to start by having some sort of memory management here. Just please try to remember even the last thing that I just did. So for that, I'm going to go into our package here, and I'm going to create just a configuration class where we can configure all the beans that go into LangChain4j. So we're going to call this our LangChain4j config. And this is just going to be a Spring Boot configuration class. And we're going to define a couple of beans. So just for bean, we want to have a chat memory provider. So this provides chat memory based on that chat ID. So we're going to say this is our chat memory provider. We need a so we're going to have a tokenizer here. Can somebody go and tell them to maybe? So we're going to return a token window chat memory with at most 1,000 tokens using this tokenizer. Let's see what's going on here. Okay, yeah. Chat ID. So again, yes. Okay, so the question here is that what happens like once our memory surpasses that 1000, it would just start forgetting the older messages. So this is pretty much how ChatGPT used to work in the beginning. You would like have a discussion and all of a sudden it forgot entirely what you told it to do in the beginning. These days it's being a little bit more smart and probably like compacting, summarizing the discussion as you're going. You could provide like this is an interface, the chat memory provider, so you could have fancy ones that would summarize or do all kinds of stuff. But for our purposes here, this is going to be more than fine. So because we're now defining a bean of this type, LangChain4j is going to pick that up, hopefully. So if we build this, wait for this to reload, we're going to try the same thing again. Hello, my name is Marcus. That. Hello. Hey, I forgot my name. What is it? What is it? Close enough. Perfect. So now it actually remembers who we are, and it's going to keep track of that memory for us, so we don't need to do that for it. Now, it doesn't know anything about our business or even who it is right now. So the next thing I want to do is go into our assistant here. I'll just close that out. And I'm going to define the system message for it. So this is us telling the AI how it should behave. Who is it? And for that, I'm going to copy over a prompt that I've created. So here I'm saying that, hey, you're a customer chat support agent for an airline called Funair. Be friendly, helpful, joyful, and you need to provide all this information before you do anything. And if you're changing a booking, you should make sure it's permitted by the terms and so on and so forth. So if we build this right now and ask it, hey, who are you? Now it's responding that it's a friendly assistant from Funair. So it's now aware of who it's supposed to be in our simulated system here. That's good. There's still obviously a problem, like it knows who it is, but it doesn't know about all of these things that we told it about. So if I ask it about, say, the cancellation policy that was in our example here, hey, can you explain the cancellation policy to me, please? It's instructed to be helpful, so it's going to try really hard to be helpful. And it's going to be helpful by just making up a whole bunch of stuff that sounds very realistic. But in reality, it's not very helpful at all, because this would be very confusing to the user trying to use the system, because none of this is even remotely true. So if we go into our project and look what our cancellation policy is, we can cancel up to 48 hours before, and there are some fees for different categories and how whatever refunds processing. So what we want to do then is go through the steps that we had on the slide. So kind of split it up into sections, create an embedding for each section, put it in a vector database, and do all of that. So we're going to go into our Lang4j config, and we're going to start setting this up. Yes, sir.
I just want to bring up like the quick thing that happened like really with Canada. So they unleashed their chatbot in production, and it made up a similar statement like we'll waive the cancellation fees for bereavement.
Yeah.
And like booked the ticket and they did not waive. They said like it's not within our policy. Our chatbot made it up.
Yeah.
Canadian government asked Canada to pay up for that.
Yeah, I saw that. So
it's a similar thing that.
Yeah, I happen to see that. So yeah, maybe a good disclaimer, don't take this and put it into production as is. If you do, don't blame me if the Canadian government sues you. All right, so what we're doing now is we're going to ingest the documents. Now, typically you wouldn't do that in the actual same app that is consuming the documents. It would be much like make a whole lot more sense to have like a build server that runs this kind of ingestion of documents whenever the documentation changes. It doesn't make sense for us to do it every time we start the application. But since we want to have a self-contained project here, we're just going to go ahead and do that here. So we're going to define a bean for the embedding model. So that's like taking a string, getting a vector. So we're going to have a embedding model. So we're going to return a new, and this is the dependency that I had for this in-memory embedding model, then we need to have a embedding store. So the vector database where we store these things, embedding store of type text segment, like that. And again, this is an interface, so this could be Pinecone, it could be Postgres, it could be Redis, it could be Astra, if Mary still allows people to use that. And anyway, so we're gonna have an embedding store, and we're gonna return a new in-memory embedding store. So this is something that comes with LangChain4j, very good for just trying around. Like neither one of these will have even remotely as good of performance as like OpenAI's embedding model and like an actual vector database, but for our simple, like trying to learn how things work without having to pay a bunch of API fees and setting up third-party things, works really great. So what I want to do next is set up a application runner that runs when the application starts, that will then find the terms of service, run through those steps that we had, and ingest it into the vector database. So we'll do a bean of type application runner, and we'll load, or let's say ingest docs. And this will need a couple of things. So we need obviously the embedding model to turn text into vectors. We need the store to actually save them. We need a tokenizer, so we know kind of how to tokenize things. And then we need a resource loader to actually find stuff from our class path. So we'll have a embedding model. We'll have a embedding store for those text segments. Call our embedding store. Then we'll have a tokenizer, because we're going to split them into chunks of a certain token size. There'll be a tokenizer. And then we'll have a resource loader. We'll call this loader. The application runner needs to return a function that essentially takes args and returns a function like this. And we obviously need to return like this. So in here, we can start doing this. So I'll do the resource source is equal to the loader dot get resource class path terms of service dot txt. And then we're going to get the actual document from there. We'll call this doc by using load document. So this is coming from LangChain4j's file system document loader, a static import. So load documents, and we need to pass in the resource file path, and then we need to tell it to use a new text document parser. So read it in the path, parse it as a document, and then we're going to create an ingester, which is something that will take in a bunch of documents and turn them into this. So we're going to say ingester is equal to a embedding store ingester, and we're going to use a builder here to give in the model. We're going to give in the store. We're going to do the splitter. So, and again, this is coming from the document splitters.recursive. So we're going to say, if we look at the parameters here, it takes a max segment size in tokens and the tokenizer that it should use to count tokens. So we're going to say we want to have, say, 50 token segments, and we want to use the tokenizer to do that. Let's see, what did I do wrong here? Oh, overlap. So we have 0 overlap between. So sometimes it can make sense, like say if you have a code snippet or something, and it like the segment would cut it in half. It might be good to have like a little bit of overlap between your segments. Not a problem for what we're doing right now. So we're going to create that, and then we're just going to use the ingester to ingest our document. There's a new helper that they just released, which just is the kind of file system loader that you can just point at a folder and it'll figure out by the extension of files how it should ingest them. It's pretty handy, at least for demos. but I didn't have time to really try it out, so I didn't want to squeeze it in here. Then what we need to do is provide a let's see, what was it called? Well, completely blanking now. Content retriever, yes. So a content retriever is what's kind of retrieving stuff from our database. So again, here we need our embedding model, so it can take the question and turn it into that vector. So this will be our embedding model. Then we need the embedding store that we're searching stuff out of. Click segment, embedding store. Then we'll return no, not ingester, embedding store, content retriever, dot builder, dot. So we give the model, so it can turn those texts into embeddings. We give the store where it can find stuff. Then we're going to say we want to have a maximum of 2 results, and they should have a minimum score of, say, 0.6. So this is something where you want to play around with different values and see what makes sense. And then we just build that like that. All right. Wow, that was a lot of code. Let's see if this actually worked. So what we did was we read the text document from the class path. We ingested it into our vector store, and then we provide a content retriever for LangChain that can access that vector store. All right, and we clearly broke stuff because it's not working. So let's see what's going on. Is not. What's that? Resource get fund. Who sees what I did wrong? Yeah. Just for the sake of right. This is how we know it's a real live coding demo, because it's not working. So let's see if that works. All right, so very clearly I typoed something, because do you see anything different from what we did? Resource get file to path. Well, I call it get path instead of to path. Thanks, Java. That was super helpful. All right, we're back on track. So let's go ahead and see if it now knows about our actual cancellation policy. Hey, can you explain the cancellation policy to me, please? All right, so now it's actually saying what we had in our terms of service. It's 48 hours before the flight. There are the different cancellation fees and so on and so forth. So now this is actually helpful to us again. Like now it's talking our business language here. But it's still not able to access any of these things in our database. And this is where adding a little bit of tools to its tool belt and kind of going over to this co-pilot mode, if you will, might make sense. So let's go ahead and define a couple of tools for it to use. So I'm going to go in here and say booking tools like this, and this it's going to be just a Spring Boot class. Come on. There we go. All right, so this is just going to be a component, and we're going to pull in this flight service. That's my backend service that I use to find bookings. Private final flight service add constructor. So I want to have three methods here: one for finding a booking, one for canceling it, and one for changing it. So let's do one for get, or it's going to return a booking details, which is just a record for holding the booking number and all that information that we have in the database. So I'm going to return one of those and say get booking details. And as you remember, we told the assistant we need to get the booking number, first name, and last name for this to work. So we're going to say we want string booking number, string first name, string last name. Speaking of copilots, let's actually turn on GitHub Copilot here for a sec. There we go. So then we'll do the same for cancel. Then we'll do one for changing. Almost looks good. The signature I have here is a little bit different, but that's okay. We can go ahead and change that. And then we'll just let Copilot take care of that. Right. Thanks, AI. Wouldn't be an AI talk if I didn't use AI to do the AI talk. All right, so we have all these methods now that are just literally delegating to my service. Now, in order for them to become available for LangChain to use, we'll annotate them with the tool. We could give like a description here if we needed to like be super specific about what this thing does, but since I happen to be very clear in my naming here, it's going to be able to figure this out without us doing that. So let's go ahead and see how this works. So the way I made my test data here is that the first person here is going to be too close to their travel to actually be able to cancel a booking. So it should say no, not allowed to do that, whereas the last person here should be able to change things. So let's start by being John Doe here and see what happens. Hi, my name is John Doe. My booking number is 101. Can you please pull up my details? All right, so that's pretty good. So we see all the same details as we have in our database here. Let's see if we can cancel it. I want to cancel my booking. Womp womp. No, can do it. We're within 48 hours, so can't do that. Good. All right, let's reload. That's going to give us a new chat ID. We're starting a new conversation. We're assuming a new identity. We are now Robert Taylor. Hey, I'm Robert Taylor. And we're going to be actual people here, not follow orders or give all the information at one point in time. I want to fly to Chicago O'Hare instead of SJC. Okay. My booking number is 105. Okay, obviously didn't work. Oh no. Yeah. All right. All right. So we gave it the wrong information. It was like, no, that's not right. Please try again. We're like, okay. Now it's like it's going to be a $50 change fee because we're an economy. It's actually pretty reasonable. Like I don't think any airline would actually let me do that, but go ahead. Please proceed. So if things go well, this should change to something more meaningful here. So let's see. And sure enough, now we're going to ORD. So we didn't like give the airport code or anything. It figured out because we're going to Chicago O'Hare, knows what the airport code is and was able to sort that out. Deal. Actually, I want to cancel my flight. So again, we're still within that window. So it's going to go ahead and do that for us. All right, so that was as far as I want to take this particular application, but I think we were already able to do, and I mean, we spent just over half an hour working on this, and I think we were able to build something that's actually fairly meaningful. Like, sure, it's not ready to go into production because Canada will hunt you down and and sue you, but otherwise it's a pretty decent app.
Right, changes our position. Like I wanted to know the cancellation policy. I want to, and I type that I want to cancel it, and it directly cancel it. So it should throw some warning first. Now, you should really want to cancel it or not?
Yeah, we should spend more time on prompt engineering here and make sure that there are like safeguards in place. I do within the actual flight service, there are safeguards against like if the actual time is like sometimes the AI is just going to be like, all right, sure, we'll cancel it even if it's within that 48-hour window. But then if it throws an exception, then it's like, oops, actually that didn't work. And so you definitely like need to be in the pilot seat and make sure that it's behaving the way it should. So like it can help you, but you need to, you're still at the end of the day, you're the one responsible. You're the one that the Canadian government's going to come after if it does wrong. So anyway, if you want to try this out, I have the same app implemented both in LangChain, which we just built, and with Spring AI up on this link here. I was up at 94 stars on GitHub, so if you want to help me reach triple digits, that would be very awesome. I am planning on doing it in semantic kernel. I still haven't gotten to it yet. It was when I last updated, semantic kernel had just redone everything and there was no documentation. So I definitely want to do it. It's been a fun project because a lot of the actual library, so like LangChain4j just did a PR yesterday to update this to the latest stuff that we work with today. Spring AI contributed the Spring AI stuff. I have a meeting with Google next week. They want to contribute to Gemini support for it. So definitely if anyone here works at Microsoft and knows anyone from semantic kernel who wants to help get that support in here, that'd be very awesome. Anyway, that's it for this talk. It was super nice to see you here. And obviously I'll be here. You can ask questions now. If you want to ask questions like one-on-one, that's also great. Thanks so much for coming. And yeah, let's open it up for questions.
This kind of gets there, kind of in a topic of AI, like fiction, like sometimes it's fun to check.
Do you want to?
All right, so the issue was with like Air Canada thing, and I think a big problem with AI, and if you go to the Reddit AI one, it's pretty funny, but
Yeah.
AI in general has a problem with hallucination where it just can't say, I don't know, I just don't know, I have to go check with someone, and how can you code this so that it won't, just a bit doesn't know and won't try to.
Yeah, so you can limit it to a certain extent. So we have two frameworks at Vaadin. One is called Flow, which lets you build everything in like Java, and one is called Hilla, the one that we're using now. And I built RAG that where you can kind of select which you want to talk about. And initially I was super strict in the prompt saying like only answer with whatever I give you. And if it's not there, just say I don't know. It was super helpful, but like realizing that our stuff is only like a small tip of the iceberg where people are having problems with Spring and with Hibernate and this and that. And then it became really unhelpful because it wasn't able to answer any of those questions. So then I started relaxing it. But you can be pretty strict and have fairly good results where it will say, I don't know, but it might then limit stuff. So there's a lot of like tweaking the prompt and still needing to kind of have some sort of safeguards in place so that you don't end up in the situation where the AI does stupid things. So especially if you're like public facing, you're giving like actual advice about stuff to a person, like you need to be able to stand behind it. If you give it access to your whatever tools, you need to have really good validation on whatever like business rule transactions are happening there, because otherwise weird things probably will happen. So yeah, good question. So yeah, you can by kind of tweaking the prompt to specifically say, like, do not answer with anything that's outside of the thing that I just handed you. You can limit the amount of hallucinations, but you can't really completely get rid of them. Good question. Anyone else? A question over here?
So I want to see like, RAG can definitely like control the hallucinations that it has. But I'm seeing like nowadays I'm using Microsoft Copilot where it gives you like the reference numbers, like
Yeah,
like the references, like whatever, like bibliographic references.
Yeah.
So how can we achieve that in this? So like it can say text terms of use dot txt line 14 where it saw the exact thing that it saw the difference from.
I think so. The LangChain4j repo, they didn't used to have documentation when I started. They nowadays actually have, like, they started working on documentation, but I think there's an example here somewhere. So essentially, I think the content retriever that we define does return that, but I think when we get the kind of the response, I didn't extract that information from it. So I think it is there, but I might be wrong, but it should be possible.
I know the assistant has support for citation.
Yeah. Yeah, I think if I recall correctly, LangChain uses the assistance API or can use it. I'm not 100% sure, but anyway, I'm fairly sure I've seen a demo somewhere where it does that.
Thank you.
All right, well, let's wrap up here. If you have more questions, you want to ask me anything, I'll be around here and obviously chat with each other. Thanks for coming, and it was good to have you.
Where you go and the favor us, if you just pick up the links. Thank you for the trash back. Yeah, it's really hard.
Okay. And,
A little bit of it.
yep, thank you, David. So first of all, thank you to Microsoft Chicago and David for, hosting us tonight, and thank you so much for coming on.